Hello students, welcome back. Now that we've moved our game from a frame-based system to a time-based system and built a difficulty ramp, we can use that difficulty ramp to implement brand new systems into our game. As of right now, our ramp is controlling one thing, and that is the rate at which our light zones shrink down in size. But we also laid the foundation for implementing an enemy system. Our ramp can control how quickly enemies spawn. So I think they'll start spawning slowly, maybe once every 5 seconds, and by the end of our game, they might be spawning once every 2 seconds. We'll also use the ramp to control how quickly the enemies move. So they'll start moving slower, and as the game goes on, they'll move faster and faster and faster. And that movement will be tracking our player. So they're going to be chasing our player as the player moves throughout the screen. So let's dive into our enemy system right now. All right, so I have lesson 6 right here, our system of pressure that we are introducing. To add a little bit of flavor text here, I'm calling my enemies light eaters because they devour the light and bring in some of the darkness. It ties into the theme of Glowfield here. And so I've got our lesson 6 starter file open in vscode.dev, but I'm going to minimize this browser tab and I'm going to open that file directly so I can see any changes that I'm making to the code. So lesson 6 starter.html. All right, let's see what we have to begin with here. All right, so here's our game. We got our player. Our ramp says an enemy should spawn in about 5 seconds, and there was no enemy spawning. So I see no enemies. Now we should at this point have like 3 enemies on the screen based off of our spawn interval. Nothing. So our shrink rate is working for our ramp, but our spawn interval and our speed multiplier, they are not operational right now. So we got to fix them. We got to implement this pressure system for enemies. So let's see how we're going to do this. Well, mission 1 right here in our checklist says to adjust the enemy system constants. Anytime we try to bring in a new system into our game, we're going to first add some constant values that we can adjust, right? These are like knobs that we can control to change how this system feels or fits into our game. And these variables are going to go right in our student edit zone. So if you look, if I scroll down, here is our next system that we're implementing, our enemy system. And so we've got quite a few variables here, quite a few controls that we can adjust to change how the enemy system works. So let's move through them one at a time because right now they're all set to 0. The first one is the maximum number of enemies that we will have on the screen at any given point. Right now it's set to 0. We want more than 0 enemies. It'd be really bad if we built this whole system, then we allowed no enemies to ever appear. So I'm going to say at most, at any given time, the most number of enemies I will have on my screen is 5. So if I have 5 enemies, do not create any more. Once I delete some or get rid of some enemies, then you can build them back up to our max number of 5. Our enemies are going to have a radius. So we're going to use circles to define our enemies as our shape, much like the player. And so we'll define the size with a radius. And let's mimic the player here. So the player's radius, yeah, right here, the player's radius was 14. So I'm going to make the enemy's radius 14 as well. So we're fair here, right? They're the same size. Okay, the enemy will track the player, move towards the player, and when they collide with the player and touch the player, they are going to deal us damage. So our enemy is going to have some strength to it. How much damage will it deal? Well, our player's health, I think the max health is 100. Yeah, the player's max health is 100. So when an enemy hits us, I'm going to drop it by 15 health points. So it'll bring us down to like 85. I think that's pretty fair. Okay, now not every enemy is going to travel the same speed. We're going to have some slow enemies. We're going to have some faster enemies. There's going to be a range of values that we can pick from for the enemy's speed. So I'm going to specify what that minimum value is and the maximum value. Our minimum value is going to be 50 pixels per second. So that's our slowest enemy. And our fastest enemy will be 3 times that value at 150 pixels per second. So that gives us a pretty good speed range to work with. Our enemies will also have health. Right now, we're not going to implement a system that allows us to damage the enemies, but eventually we will because we want to be able to take these enemies out. We want to protect ourselves. So when we do that, we will say, all right, the enemies are going to have 100 health to begin, and if that health gets to 0, then the enemy will be dead. And lastly, a very important value here is the enemy hit cooldown in seconds. So we know that when an enemy touches us, it's going to deal us 15 points of damage. So imagine right now if my mouse is an enemy, it tracks us, and right there it deals us 15 points of damage. But on the next frame, the mouse is still touching the player. Even if the player tries to move just a little bit, the mouse is still going to touch the player. Another 15 points of damage is dealt. Another 15 points of damage is dealt. And so we will create something called a cooldown. For each enemy, once it deals damage, there's going to be an amount of time we have to wait before it can deal damage again. This will give the player enough time to get away from the enemy. And we'll set this to a small value, 0.75 seconds. All right, mission number 1 is complete. Our constants for the enemy system are now in place. Let's just scroll and see what else we got in our student edit zone. We've got, look, we've got some colors here for our enemy system. We got an enemy body color, which is a solid color that has all of the red and just a little bit of blue and green, so a nice red color. And we've got a enemy core color for like the center part of our enemy, which looks like it is black, and it is got some transparency to it. So we're going to be able to see behind that core. If I go a little bit lower in our gameplay variables, what new gameplay variables do we have? All right, we have an array called enemies. This is going to be the container that we put all of the enemy objects that we create into. And then I have a variable called enemy spawn timer seconds. Right now, if I restart my game, my enemy spawn interval, which is set by my ramp, is 5 seconds. So that means after 5 seconds has elapsed, I will spawn an enemy right now. But then at that point, when we spawned the enemy, what did our spawn interval? It was like 4.8 maybe. So now we're going to spawn our next enemy at 4.8 seconds. So eventually this variable will change its value. It'll be 5, and then when we spawn an enemy, it will be whatever the ramp tells it to be, 4.8. And then the next time it'll be whatever the ramp tells it to be, 4.3, I don't know. And it'll keep going down and down and down until it reaches our lowest possible spawn time. Okay, so now that we know what our variables are, let's go to mission number 2. So our mission 2 tag is all about setting up the enemy data object. So remember, we have to define the data for our systems. So here we are in a generate enemy data function. This seems really familiar. If I go up just a little bit, when we implemented the light system, we had a generate light data where we returned our data object. We had a spawn light function which called that generate light data function, and then we updated our lights. So anytime we implement a new system, we're going to try to generate the data for that system, spawn an object for that system, and then update all of the objects that are a part of that system. And our enemies are no different. If we look here, we have generate enemy data, which creates an object for us, returns it. We have a spawn enemy, so we're spawning that data, which is calling that generate enemy data, and it's pushing it into an array. And then we're updating all of the enemies that we have created. So this system is going to be repeatable for us. So right now, we got to define the data first. So it says complete the enemy data object, include position and speed values for movement. So here's our object. And right now, our enemy has 5 properties: X, Y, speed, HP, and hit cooldown seconds. Right now, anytime we create an enemy, the X and Y property is 0, so that's going to be the center of our circle at 0, 0, and its speed is 0. That puts our enemy right here in the top left corner of our screen, motionless, anytime we create an enemy. Not what we want. In fact, when I spawn an enemy, I want my enemy's spawning position to be randomized. I don't want to know where the enemy is going to spawn, so I'm going to use the random function. And we want to set the range of values with which we could pick for its X position. So maybe I'll do 0 to the width of my canvas. But if you look here, right, 0 is the X position is going to be specified by the enemy's center of the circle. So if I do 0, that's going to put the center right here, which means half of the enemy is going to be off the screen. So I really want to shift that back in by a certain amount. That certain amount is the radius of the enemy. So instead of 0, I'm going to do enemy radius. And if we go all the way to the end of the screen, half of the enemy is going to be off the screen. So I want to go back by the radius. Tab for autocomplete is our friend. In the Y direction, we're going to do something similar, except if we think about it, we don't want our enemies spawning up here in the HUD. So we're not going to use 0. We're going to use the HUD height and then shift it down by the enemy's radius again. So we'll use the random function to randomly select our Y value, and we'll say we'll start at the HUD height, and then we're going to shift down by the enemy's radius. So the center of the player, or I'm sorry, the center of the enemy is now in our playable window. And we'll go all the way down to the height of our canvas, but then we'll subtract the enemy radius to bring them fully back up into our battlefield. All right, now that's going to randomly create our enemies in any position. So we can create one here, 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 here. But they're all motionless. The speed is set to 0. So we have to give them some speed. We could give them a speed of, say, I don't know, 100, but then every enemy is going to be traveling at the same speed. We don't want that. So we know that we've already set for mission 1 a minimum speed and a maximum speed to choose from. We're going to pass those into the random function. So we'll do random enemy min. Oh, you got to spell enemy right. I got to spell enemy right. Enemy min, there we go, enemy speed min, that was the name of the variable, and then enemy speed max. All right, so that's pretty great. There's only one problem here. As the game progresses, we have stated that we want the speed to increase, right? We want our enemies to move faster and faster and faster. Right now, they are always stuck between 50 and 150 pixels per second. But we've got this value right here, our enemy speed multiplier. As the game goes on, it gets bigger and bigger and bigger. And so that's controlled by our ramp. So I'm going to multiply by our enemy speed multiplier. And let's just take a look at what that's going to do for us. So let's just assume at the start of the game, the enemy speed multiplier, I believe it starts at 1. So let's say we pick a speed of 100 and I multiply by 1. So the speed of that enemy is going to be 100. As the game goes on, the enemy speed multiplier increases from our ramp. So let's say now it's at 1.3. Well, that same enemy who gets created with a speed of 100 is now going to be moving when it is created at a speed of 130. If another enemy is created later on in the game where the speed multiplier is, say, like 2.1, and we randomly picked a speed of 100, well, then it's going to be moving at 210 pixels per second. So it's going to keep increasing and increasing the speed of our spawned enemies. So I think that's perfect. Our other two properties, our HP, that's great. It's set to our enemy's max health. And our hit cooldown seconds is currently set to 0 because the enemy hasn't hit anybody yet. So there's no need to set a cooldown. So I think this enemy object is complete. So let's move to mission number 3. Mission number 3 is all about spawning our enemies. It puts us inside of our update enemies function, the third part to our enemy system. Remember, we generated the enemy data, we're spawning our enemies, and now we're updating our enemies. Before we get there, let's just look at what spawn enemy has for us. It asks a question. It says, if the length of the enemies array is greater than or equal to our maximum number of enemies, meaning how many enemies are in our container? And if it's more than our max enemies, which is just 5, we return. We get out of this function. We stop. We don't have to do anything. We've reached the maximum number of enemies we should have on the screen. But if this question is no, then what do? Well, we push a brand new enemy into our container. And that brand new enemy is coming from our generate enemy data function right here. So we got to probably use this spawn enemy function here in mission number 3. It says, hey, right here when we update our enemies, we take the enemy spawn timer seconds variable, which what's it set to begin? I think when we start the game, it is, let's just see, let me refresh the game. When we start the game, it's set to 5 seconds. We're going to decrease it by our delta t. So it'll be like 4.9, then 4.8, 4.7, 4.6, all the way down. And when it finally hits 0, if it is less than or equal to 0, we want to spawn an enemy. So we're going to spawn an enemy using our generator function. So I'll just say spawn enemy, just like that. And let's run this. Let's see what happens. Are we going to get one single enemy at 5 seconds? So here I am at 5 seconds. What do we get? Whoa. Look at whoa, there's a lot of enemies spawning here. That's not the right behavior. We spawned, and look at, they're just these little tiny dots, but we spawned like a ton, and they all spawned immediately. We don't want that. We only want to spawn one single enemy. Well, what's happening is our spawn timer hits 0, right? So we spawn an enemy. And then the next frame, we subtract DT. So now our spawn timer is in the negative. It might be like negative 0.1, which makes this true. So we spawn another enemy in the next frame. And then we spawn another enemy in the next frame. The problem here is we're never resetting the spawn timer. So once we create an enemy, we're going to reset our spawn timer. So how do we do that? Well, we're going to take that variable, enemy spawn timer, seconds, and we're going to set it to whatever the spawn interval is from our ramp. So remember, this is controlled by our ramp. Let's just go to our update ramp function really quick and look at this. So here's our update ramp values. We have the enemy spawn interval. That is going to be somewhere between 5 seconds and 2 seconds, controlled by whatever the ramp value is. So we're going to use that value. So we're going to take our enemy spawn timer and set it to whatever the current enemy spawn interval is. All right, now we should only spawn one enemy at a time. Let's take a look. All right, at 5 seconds, one should spawn. All right, and where did it spawn? It's super hard to see. It's like right down here. They're really hard to see because they're just these little like globs. Oh, there's our second enemy, so our second one spawned. There's our third one, so our third one is spawning, and they're spawning at the right time. So that's great. This system is working, but it's working poorly because I cannot really see our enemies. So let's head to mission number 4. Mission number 4 puts us in our draw enemies function. Very good. So hopefully we're going to fix that issue of not being able to see what's going on. Mission 4 says draw the enemy body details. Make enemies clearly visible in the world. Well, if you look, what are we drawing right now? We're drawing their core. So we're filling our paint bucket with our core and drawing the core color. And that's that transparent black. Yeah. So that's why we can barely see them. We're not drawing that nice red we talked about. So before we fix this, let's just see. We're in draw enemies. And draw enemies is coming from draw scene, right? Where we draw our background, our lights, our enemies, our player, our HUD, our overlays if conditions are met. And where's draw scene being called? I just want to review it. If we go up here, we've got these two default functions from the P5 library. Setup, which runs once when we start our game. So right now, it just ran. And then this draw function, which runs every single frame. If our game mode is equal to play, we update our ramp, update our player, update our lights, update our health. We update our enemies. So we're calling that function. And look, we got a new function here, check player enemy collisions. So those are going to run every single frame if our game mode is in play. And then we call draw scene every frame regardless. So draw scene gets called every frame. Perfect. So now let's look at draw enemies. No stroke. That means give me an invisible marker so you're not about to see the outline of the shape that I'm going to draw. And then we're looping through our container or array of enemies. So for every single enemy that's in that container, we are going to run these lines of code. So we are drawing the core color. We just got to draw the body color. And we're going to draw the body color first so the core sits on top of it when we draw it afterwards. I should put a new color in my paint bucket, and the color is going to be our enemy's body color. So enemy body color, that's that red. You can see all of the red right there in that channel, FF. Give me all the red. And now that that paint is in my paint bucket, we're going to draw a circle. So circle, and we're going to draw it at enemy.x, enemy.y, and how big do we want this circle to be? So I want it to be like twice the size of this circle. So I'm going to do enemy radius times 2. So that's the true diameter. When you take a radius and you multiply by 2, that's our true diameter. That's going to be the actual size we wanted the enemy to be. Now we should see our enemies nicely. Let's take a look and let's see how are they going to look and how are they going to respond. All right, so there's one enemy. Ooh, that looks pretty good. I like that. Oh, it's sort of chasing me. Oh, there's our second enemy. He's sort of chasing me too. I don't know, are they chasing me? It's weird. So they're like, okay, he got to me, and he's tracking me in the X direction. So is this one, right? If I move over here, they track me. If I move over here, they track me. But they're not tracking me at all in the Y direction. It's like they know where they need to go horizontally, but they don't know where they need to go vertically. So we got to fix this enemy tracking system. We want to update our enemy movement so that they move towards the player. And this is going to put us in mission number 5. Mission number 5 finds us in the update enemies function again. We've already looked at spawning our enemies here, but now this is going to be moving our enemies. So we loop through our array of enemies, and for every single enemy, what are we doing? Well, it looks like we're calculating a dx, a dy, a length, and then we've got, I don't know, enemy.x plus equals dx over len times enemy speed times dt. I don't know. This line is confusing, but the horizontal movement is working, and I think that's our horizontal movement. Our vertical movement is broken, and if you look at our vertical line, it just says enemy.y plus equals 0. So that needs to be fixed. I think before we go and fix this, we got to do a little bit of explanation as to how we implement enemy tracking, so player tracking for our enemies. So let's head over here to our whiteboard and let's take a quick look. The first thing that we're going to say is that when we talk about speed of an object's speed really has 2 parts. So I can say, all right, so let's see, speed has 2 parts. It has a direction. So what is the direction you need to move in? And it has a size. How fast do you need to move in that direction? And so the size, we already know how fast our enemies are moving. It's going to be their enemy.speed. It's their speed property. But we have no idea what direction they need to move in, okay? We have no idea. So we got to figure out this direction piece of the puzzle. All right, so how do we go about doing that? Well, let's first start by drawing, let's draw a picture. So let's assume that I've got my player right here, and there's the center of my player. And then I'll have an enemy way over here. And here is the center of my enemy. All right, and so we can figure out how far away we are. We know we got to sort of go in this direction. The enemy's got to go all the way over there. And we've drawn a triangle before that sort of mimics this. This is known as our length. That's how far away we are, the length of our distance. And we can take that length and think of it as having 2 parts. It has a horizontal part right here, and it has a vertical part right here. And we called those horizontal and vertical parts dx and dy. All right, so I'll say maybe this is like our x part of the length, and this is our y part of the length. So far, so good. Not too bad. Now, if we look here, we can't actually use this length arrow as our direction. Can we use this as our direction? The answer is no. And here's why. That arrow changes its size. So if we look here, as our enemy moves closer, now imagine if my enemy, so here's my player. Now imagine my enemy just got closer. So now my enemy has moved along that arrow. The length is smaller. So the length arrow is smaller. dx is smaller. dy is smaller. That's problematic. We want to we'll put a bullet right here. We're going to say, okay, we'll say the length arrow gets smaller as we move closer. So that's not good, because if you think about it, if this is changing its size, right? If this was like 15 right here, if it was 15 and then it became 4, when we use that, the overall speed is going to change. We don't want the speed to change. We want some number that is going to be our length arrow that is always constant. We want a constant value for that length arrow. And that way, that length arrow is only going to give us our direction. So we'll say we want an arrow that is always some constant number. Well, what constant number could we use to multiply by our speed that would really never change our speed? Because like if our speed is 5, let's just say the speed is 5 and the length of this arrow is 4. Well, 4 times 5 is 20. So we'd be moving 20 pixels per second in this direction. And then when we get here, if the length of this arrow is only 2, Well, 2 times 5 is 10. We'd be moving at 10 pixels per second in this direction. We'd be slowing down. That's not ideal. So the magic number that we can always multiply by and not change the value of the thing that we're multiplying it with is 1. So we want an arrow who is always going to have a size of 1. And that will give us, this gives just direction. This gives direction. Direction only. All right. So how do we go about doing that? Well, recall the Pythagorean theorem, which says a squared plus b squared is equal to c squared. There is a known formula that says if you take the sine of some angle and square it, a squared, and you add the cosine of some angle and you square it, b squared, you get 1 squared. Hey, that's the Pythagorean theorem, c squared. Let's draw this triangle out. So if I put a triangle right here and I make my sides here, I'm going to put cosine of theta, sine of theta. That triangle, it gives me an arrow whose length is equal to 1. So this is our A, this is our B, and this is our C. Now I know I drew A over here and B over here. Really, these are interchangeable, so you can flip-flop A and B. So what we need to do is we got to figure out how do we get the sine of an angle, and here's our angle. It's right here. It's right here. It's right here. How do we get the sine of that angle, and how do we get the cosine of that angle? What does this do for us? Because if we can figure those out, this length of value 1, which is exactly what we want right here, has an x part, the x part of our direction, and it has a y part, the y part of our direction. All right, well, let's just take a look here. We can introduce just a few more formulas, and then we're done with math, I promise, but it's important for us to at least understand the code that we're doing. We can say that the sine of any angle is equal to the opposite side of that angle divided by the hypotenuse of that angle. So if we look here, sine is here's my angle, opposite that angle is dy. The hypotenuse of our triangle is our length. And cosine of theta is defined as the side adjacent to the angle divided by the hypotenuse. So adjacent to our angle, theta, is dx, and our hypotenuse is length. And that right there is the super important part, because dx divided by our length is nothing but the x part of direction. It's the x part of the direction that we need to move in. dy divided by the length is nothing but the y part of the direction that we need to move in. This is super important because now we have a way to get the direction of motion without changing the size of our speed. And we're going to leverage dy over length and dx over length, sine and cosine of our angle, to track the player. So let's go back now and look at what we're doing. For every enemy, we're calculating a dx, which is the player's x position minus the enemy's x position, a dy, the player's y position minus the enemy's y position, and then we're getting the length between those two objects, right? The player and the enemy. So we're using the Pythagorean theorem, the square root of a squared plus b squared. Now, that is this value right here. Zoop, zoop. But if you look, we're saying, hey, if that size is less than 0.00001, we're just going to continue. We're going to skip over the rest of the code for this enemy and move on to the next one, because this is all about moving the enemy towards the player. And if the length is so small, that means the enemy is right on top of the player already, and we don't need to move them anymore. And so now let's look at what's working. If the enemy is not on the player, we want to move them towards the player. We update the enemy's x position by taking the x part of the direction, dx divided by length, and we multiply by the size of the enemy's speed. Recall, the start of our math conversation, we said, hey, speed has two parts. It has direction, it has size. So we're taking the size, which we know, it's the speed attribute of the enemy, and we're multiplying by the direction it needs to move in, just the x direction. And then we take that and multiply by dt to keep it constant. So now we need to mimic this structure for the y direction, except we're going to use dy over our length to get the y part of our direction. So let's implement that now. So we'll say, all right, we're going to update the enemy's y position by doing dy over length. That's the direction that they have to move in the y direction, times enemy.speed. That's the size they need to move in the y direction. And then we're going to multiply that by time to keep it consistent. And just like that, we should have full enemy tracking. So anytime you want something to follow another object, this is a great system that you can use. And look at that. That enemy is following us in the horizontal. And if I move, well, let's try one more time. So I can have great horizontal tracking. All right, so great horizontal tracking. And if I shift up here, vertical tracking. Horizontal and vertical. Look at that. They're just chasing me right around the window right now. So I'm really, really happy with our enemy movement system. So now the enemies are going to move towards the player. They're eventually going to collide with the player. So let's look at what mission 6 has us doing. It puts us in a function called check player enemy collisions. We know that this gets called every single frame because we saw it in our P5 draw function. So for every enemy in our array of enemies, what are we doing? Well, we're calculating a dx, a dy, and like a hit zone. This is our circular collision check using the Pythagorean theorem. We emulated this just like we did in our check object light collision. See, we did the exact same thing here. We're going to mimic that down here. So now we just got to implement what happens when an enemy actually collides with the player. Well, right now we're taking the enemy's hit cooldown seconds property and we're setting it to 0. That is not right. We actually got to set it to some value so that we don't, so that we don't get damage over and over again. So let's set it to enemy hit cooldown seconds, right? We set that as a constant. So it's going to be set to like 0.75. So once the enemy collides with us, we have 0.75 seconds before they can deal damage to us again. But we actually have to deal the damage. Right now, our health is being decreased by 0. So instead, we're going to subtract our enemy's strength from our health. So that'll be 15 points. And then our health could go negative. I don't want it to go negative, so I'm just going to do a constrain here. I'll do constrain. We're going to constrain our health between 0 and max health. All right, so now when we collide, and that collision math is already set for us, we should start to take damage. Let's see, can the enemies track us and can they damage us? All right, here comes the enemy. And we've got no damage. We should have gotten some damage. Maybe I just didn't click off of the... Maybe I gotta click off of that. Let's try one more time. All right, here comes our enemy. Oh, and we took a lot of damage. In fact, it dropped us down to like 0. And then as soon as I left, then I died. So that's not right. So it seems like as soon as the enemy touched us, we just took damage over and over and over again. It looks like our cooldown system is not working. So let's look at mission number 7. Good. Mission 7 is all about getting that cooldown system working. It says we have to actually update the enemy hit cooldown. And if the cooldown is greater than 0, we're going to skip over this particular enemy because they are not allowed to deal us damage again. So if you look right at the beginning of this loop, we're taking that cooldown, which we had set to, 0.75 seconds? And we just set it right to 0. Well, that's silly. We don't want to do that. What we want to do is we want to subtract dt. So we can say minus equals dt. Now, if, it just says if false, continue. Well, we want to ask a question. We want to ask a question that will get us to continue or skip over this bit of code here for the enemy that we're on and go on to the next enemy. We want that to happen if our enemy's hit cooldown. So if enemy.hit cooldown seconds is greater than 0. So if that has some time on it, we're just going to continue and pass over this enemy and go to the next one. So let's run this now. Now we should see that we're only going to take damage once, I hope. Let's see. All right, here comes our enemy. I'll go to it. All right, I took damage. I took damage. You can see I have a bit of a cooldown now, so that works really great. There's only one slight problem where our cooldown, we're subtracting from it, and it eventually will get to 0, and then we're going to continually subtract from it. So I don't want it to go negative. So what I'm going to do is change how we write this line. I'm actually going to set it equal to the max function, and I'm going to provide two values, 0, and then enemy.hit cooldown seconds minus dt. So we're going to take whatever is in the cooldown, and we're going to look at it subtracted by dt, and then we're going to compare that number to 0, and we're going to pick the largest of the two and update our value this way. So this will say, okay, the lowest possible value we will ever get is 0, because if our enemy hit cooldown is at 0 and we subtract dt, maybe this is going to be like negative 0.1. The maximum number between negative 0.1 and 0 is 0. So this will guarantee that our cooldown is always going to be at 0. All right, so now mission 7 is correct. Let's look at our last mission, mission number 8. We got to check for game over here upon losing health and set the game mode accordingly. So you can see here, when we lose health, we got to say, okay, is it time to end the game? Well, we set current game mode to game mode.lose, so that's pretty good. We're just not asking a question. So what will trigger setting the game mode to lose? Well, it's going to be whether or not the player's health property is less than or equal to 0. If that happens, then it is game over. And with that, I believe our enemy system is complete. Let's test it. Let's play it out. We have enemy tracking. Our enemies look great. They move towards the player. They actually chase the player. All right, and let's take some damage by them. Boom, boom, boom. Our cooldown's working. And as soon as they remove all of our health, we have faded. And the enemies have won. They've won for now. But we have got at least, 2 more lessons to help the player. We'll build some systems that can help the player, because right now it's sort of unfair. This poor player, their one singular light zone is shrinking and shrinking and shrinking. And now we are spawning enemies that are going to chase them all over, dealing damage. There's no way for the player to fight back. And our next 2 lessons will equip the player with some systems that can allow them to survive longer and deal some damage back to our enemies. So I'll see you in that next video.